Hey, hope you're all doing well. This is a video in regards to the Joranalogue's new Walk 4. I know that's not what we're looking at here. The module's not out yet, but I thought I like to kind of study modules, see if I can reverse engineer what's going on with them and make them out of individual components. It's like we have modulars. Maybe we can figure out how to patch this on our own. So I came up with this. It's not exact, but it's pretty interesting. It's 2 sample and holds in a feedback loop with a precision adder or mixer. Right there, I used a precision adder. So over here, you've got your 5-volt source, or your incremental source, I should say. So Walk 4 actually takes a analog voltage and adds it right in a feedback loop. This one's counting up and down. If you set your compare to correctly, your shift, you can just get it to count up and then restart. But it's been a bit challenging. I ended up having to use a flip-flop and an inverter. All right, so let's get into the schematic here. So your incremental source voltage is here. All right, it comes in, it gets inverted. So you've got 2 copies, one inverted, one straight up, going into a switch. The switch feeds into a mixer or a precision adder, right, into the first sample and hold. The second sample and hold is feeding back to the precision adder through a potentiometer. This guy right here, you notice it's cranked all the way up. We'll have some interesting effects on the feedback loop. All right, top square is your comparator. Compare to, we're using that as a window comparator, right? And we're using the not output right here. Right? And then that's cruising over to our flip-flop. And then that's working our SL3KT right here. I dropping it back and forth. See that? Yeah. So, yeah. So, sounds like a triangle wave through a sample and hold, right? But it's actually using this voltage. Where are we in the spaghetti? This guy right here. Right? Yeah. Hearing that? So, right? Change the incremental voltage. You get this, right? It counts faster. Slow, right? Smaller increments. All right, and then on the feedback loop, it's pretty interesting. It actually, like, right, stops. Yeah. Right? Right, okay, so that, right, it gets stuck. You can hear it's like the cap and the sample and hold start to drain. It's an interesting little feedback loop that's happening right there. All right, so then in order to get these sample and holds to activate correctly, right, because it's like a read in, increment, read in, increment, you need a trigger delay. So here's your trigger in, right, and so you need to delay that second trigger, right, to that second sample and hold. So it's pretty interesting stuff. Pretty interesting stuff. Yeah. Huh. All right, so there's the sample and hold. I'm using the SL3. Right. Here's my propagate. That's my gate delay. I'm using compare to as my window comparator. And it says you take your shift control. You can start making it just right. Count up and stop. That's it. All right, let's go. All right. We're starting to lose it again, so we'll go back down with our increment here. Yeah. So of course, this isn't how walk 4 works, right? This is like, it counts up in steps, your incremental steps that's, set by your initial voltage. But it's an interesting little feedback loop that's begs exploration. So if you have these individual modules, give this a try. It's got some interesting results going on. It's like you can vary all these things, and of course that potentiometer could be a VCA. Same with that feedback loop right there, right? You could put VCAs in a number of spots here. All right, and give that a try, see what you think. I thought it was pretty interesting. All right, so there's me like checking all the signals and seeing the results. And the sky's the limit with this sort of way. All right. Yeah. All right. Let's give that a try. See what you think. It's not exact. And I think it has some applications towards atmospheric electrical energy collection. Check out Alexei Chekhurkov's atmospheric electrical video. We'll take this and apply it to charging a bank of capacitors. All right. Happy Thanksgiving. Thanks for watching.